Now, I want to talk about numerical optimization, which is a mathematical tool we can use for adaptation and robustness. For example, I have a function fx, which is equal to x squared plus 4x plus 5. And I want to find out x opt or optimal x, which makes our function fx minimum. One way of doing this is finding slope or f prime x, and you let that equal to 0 and find x which satisfies this equation. So what is f prime x or dfx dx, which is the derivative of fx with respect to x, is 2x plus 4. And you let this equal to 0, then you have this x optimal, which is minus 2. Now we can plot this function. If x is 0, we have 0 here and 0 here and 5 here. So when x is 0, we will have 5. And we know that when x is negative 2, which is this point here, we will have a minimum. And that value will be f minus 2, which is minus 2 squared plus 4 times minus 2 plus 5, which is 4 minus 8 plus 5, which is 1. And this will be 1. So our function will be something like this. We have a minimum at negative 2, and then we have a vertical axis intercept, which is 5. This approach is called Analytical Optimization. So this is different from Numerical Optimization that we want to talk about. We have this function here. We use some sort of rules or formulas in order to find out this optimal value. Now, I'm going to show you another way of approaching optimization problem, which is numerical optimization. Again, we have a function, which is a parabola, and our goal is to find x value, and we may call it x opt, which makes our function f of x minimal. First, we pick any x. We call that x opt of 1. So it's like first candidate for this optimal x value. Draw a tangent line at this point, and we find the slope. And you see that this slope is negative. And if our slope is negative, then basically we move our x opt of 1 in the positive direction or to the right in order to pick the next candidate. Let's say our next candidate is here, x opt of 2. And at this point, you again find the slope, and you see that also the slope is negative. So because this is negative, we want to move in the positive direction again. So again, this is the positive direction. Your candidate is here. So this is your candidate, and that value is x opt of 3. So now you are here, and you find the slope again. And we see that the slope is now positive. And if the slope is positive, we want to move this x opt of 3 in the negative direction, the opposite direction. From here, we go in a negative direction, and this point can be x opt of 4. So if the slope is negative, our x opt candidate, let's call it x opt of integer n, moves in the positive direction, which is the opposite of this negative slope. If the slope is positive, then we move our candidate in the negative direction. And mathematically, this can be expressed like this. So x opt n plus 1 is equal to x of n minus mu times slope at x of n. And I need to put opt here and opt here. This n is, again, integer. And for this specific case, we can say greater or equal to 1. And also this mu is just a constant. It's called a step size. It's a positive number. It's a real positive constant. If n is 1, then we have x opt of 2 is equal to x opt of 1 minus some positive constant mu times slope at x opt of 1. if you look at this value, slope at x opt of 1, this is the slope. And it's a negative value. So this is a negative value. And we know that this value is positive constant. And we have this negative sign here. So this is a negative and this is a negative. So this expression is a positive value. This means that you have this previous candidate and you add some positive number to this candidate. In other words, you move this candidate in the positive direction. So from here to here, then you get this next candidate, right? This is basically what's happening. How about if n is 3? So I'm skipping n is equal to 2. If n is 3, then x opt 4 is equal to x opt 3 minus mu times slope at x opt 3. And the slope is positive. We have a positive value here. And this one, again, is positive, which is step size. And we have a negative sign here. So this expression here represents a negative number. In other words, in order to find out this next candidate from here, we need to subtract some number. We go from here to here, which means that we move our candidate in the negative direction. And if you continue these steps over and over, you may reach this optimal value or close to this optimal value eventually. And this method is called gradient descent method. And gradient means a slope.